When a motor is protected by time delay fuses at the motor disconnect, this provides motor short circuit protection. However, the feeder circuit breaker in the panel must still be sized at 250% of the motor's full load amps, or floor, to accommodate the starting inrush current. The time delay fuses are designed to protect the motor from short circuits, but they do not provide adequate protection for the feeder circuit against the high inrush current experienced during motor starts. This inrush current can be significantly higher than the motor's FLA, potentially reaching up to 6 times the FLA. Therefore, the feeder circuit breaker needs to be sized to handle this elevated current. Sizing the feeder circuit breaker at 250% of the motor FLA is a common practice to ensure that the breaker does not trip unnecessarily during motor starting while still providing overcurrent protection. The National Electrical Code, or NEC, provides specific guidelines for motor circuit protection, including the sizing of fuses and circuit breakers. These guidelines are designed to protect the motor, the feeder conductors, and the electrical system from damage due to overloads, short circuits, and ground faults. When selecting fuses for motor protection, time delay fuses, also known as dual element fuses, are often used because they can withstand the temporary inrush current that occurs when a motor starts without opening the circuit. These fuses have a built-in time delay that allows them to pass the high inrush current for a short period of time, while still providing protection against sustained overloads and short circuits. The sizing of time delay fuses for motor protection is typically based on the motor's FLA, with the fuse rating selected to be within the range specified by the NEC. The NEC provides tables and guidelines for determining the appropriate fuse size based on the motor's horsepower, voltage, and other characteristics. In addition to fuses, circuit breakers are also commonly used for motor protection. Circuit breakers are electromechanical devices that automatically interrupt the circuit when an overcurrent or short circuit condition occurs. They are available in various types, including standard inverse time breakers, instantaneous trip breakers, and adjustable trip breakers. Standard inverse time circuit breakers provide overload and short circuit protection, with the tripping time inversely proportional to the magnitude of the overcurrent. Instantaneous trip circuit breakers, also known as motor circuit protectors, are designed to trip very quickly in response to high fault currents, providing protection against short circuits and ground faults. Adjustable trip circuit breakers allow the user to adjust the tripping current and time delay settings, providing flexibility in tailoring the protection to the specific motor application. When selecting a circuit breaker for motor protection, it is important to consider the motor's FLA, the starting current characteristics, and the application requirement. The circuit breaker should be sized to handle the motor's starting current without nuisance tripping, while still providing adequate protection against overloads and short circuits. The NEC provides guidelines for sizing circuit breakers for motor protection, including the use of specific multipliers based on the motor's design and operating characteristics. In addition to overcurrent protection, motor circuits also require protection against undervoltage conditions. Undervoltage protection, also known as low-voltage protection, is designed to prevent the motor from restarting automatically after a power interruption. This is important because the sudden restart of a motor after a power outage can cause damage to the motor, the driven equipment, and the electrical system. Undervoltage protection can be provided by various means, including undervoltage relays, magnetic starters with undervoltage release, and solid-state motor protection devices. These devices monitor the voltage of the motor circuit and automatically disconnect the motor if the voltage drops below a predetermined level. They also prevent the motor from restarting until the voltage has returned to a safe level and a manual reset is performed. Ground fault protection is another important aspect of motor circuit protection. Ground fault protection is designed to detect and interrupt ground faults, which are unintentional electrical connections between a live conductor and ground. Ground faults can cause severe damage to equipment, create fire hazards, and pose a shock hazard to personnel. Ground fault protection can be provided by ground fault circuit interrupters, or GFCIs, ground fault relays, and other specialized ground fault protection devices. These devices monitor the current balance in the motor circuit and automatically disconnect the circuit if a ground fault is detected. The NEC requires ground fault protection for certain motor circuits, particularly those operating at higher voltages or serving critical loads. Motor control centers, or MCCs, are commonly used in industrial and commercial facilities to house and control multiple motor circuits. MCC provide a centralized location for motor starters, circuit breakers, fuses, and other motor control components. They also provide a convenient means of wiring and protecting motor circuits. MCC are typically designed to meet specific industry standards and are available in various configurations to suit different application requirements. When designing a motor circuit, it is important to consider the applicable codes and standards, including the NEC, the National Electrical Manufacturers Association, or NEMA, standards, and other relevant industry standards. These codes and standards provide guidelines for the selection, installation, and protection of motor circuits. It is also important to consult with a qualified electrical engineer or electrician to ensure that the motor circuit is designed and installed in accordance with all applicable requirements. Proper motor circuit protection is essential for ensuring the safe and reliable operation of motors and electrical systems. By selecting the appropriate fuses, circuit breakers, and other protective devices, and by following the guidelines of the NEC and other relevant standards, it is possible to protect motors from overloads, short circuits, ground faults, and other electrical hazards. Therefore, when sizing a feeder circuit breaker for a motor, even if time delay fuses are used at the motor disconnect for short circuit protection, you must still size the feeder circuit breaker in the panel at 250% of the full load amps of the motor due to the inrush current. The time delay fuses primarily protect the motor itself from short circuits, while the feeder breaker safeguards the feeder conductors from overload and handles the initial high current draw during motor startup. Neglecting the inrush current when sizing the feeder breaker can lead to nuisance tripping, disrupting operations. Always refer to the National Electrical Code for specific requirements and calculations related to motor circuit protection. Firstly, determine the motor's full load amperage from the motor nameplate. Secondly, multiply the full load amperage by 2.5 or 250% to determine the minimum size of the feeder circuit breaker. Thirdly, select a circuit breaker with a standard rating that is equal to or slightly higher than the calculated value. Fourthly, verify that the selected circuit breaker meets the interrupting rating requirements for the system. Fifthly, ensure that the feeder conductors are sized appropriately to handle the ampacity of the circuit breaker. Sixthly, install time delay fuses at the motor disconnect for short circuit protection, selecting a fuse rating that is appropriate for the motor's full load amperage and starting characteristics. Seventhly, properly label all components and circuits to ensure easy identification and maintenance. Eighthly, conduct regular inspections and testing of the motor circuit to verify that the protective devices are functioning correctly. Ninthly, keep accurate records of all motor circuit components and maintenance activities. Tenthly, consult with a qualified electrical professional if you have any questions or concerns about motor circuit protection. Remember, proper motor protection involves a coordinated approach, using both time delay fuses and appropriately sized circuit breakers to safeguard the motor and the electrical system. Neglecting any aspect of this protection can lead to equipment damage, downtime, and safety hazards. Always prioritize safety and consult with qualified professionals to ensure the proper design, installation, and maintenance of motor circuits. The NEC provides detailed tables and guidelines for motor circuit protection, including specific requirements for fuse and circuit breaker sizing based on motor horsepower, voltage, and other factors. Familiarize yourself with these requirements and follow them carefully to ensure compliance and safety. Additionally, consider the specific application and operating conditions of the motor when selecting protective devices. For example, motors operating in harsher environments or with frequent starts and stops may require more robust protection than motors operating in milder conditions. Also, be aware of any local codes or regulations that may supplement or modify the NEC requirements. These local codes may have specific requirements for motor circuit protection that must be followed. Regular maintenance and testing of motor circuits are essential for ensuring the continued effectiveness of the protective devices. This includes inspecting fuses and circuit breakers for damage or deterioration, testing the tripping characteristics of circuit breakers, and verifying the proper operation of ground fault protection devices. Any faulty or suspect devices should be replaced immediately. Finally, remember that motor circuit protection is not a one-size-fits-all solution. The specific protection requirements for each motor circuit will depend on a variety of factors, including the motor's characteristics, the application, the operating environment, and the applicable codes and standards. Take the time to carefully evaluate these factors and select the appropriate protective devices to ensure the safe and reliable operation of your motors and electrical systems. In summary, while time delay fuses at the motor disconnect provide crucial short circuit protection for the motor itself, you must still adhere to the NEC guidelines and size your feeder circuit breaker in the panel at 250% of the motor's full load amps to safely accommodate the inrush current during motor startup and prevent nuisance tripping. This dual protection approach ensures both the motor and the feeder circuit are adequately protected against various electrical faults.